Merry Christmas and Happy Holidays. Today I have a cool little video for you guys. It's going to be very different than what I normally do. It's going to be like a skit type video. I'm going to be doing basically just teaching calculus concepts at different levels of education. So I'll show you guys what I mean throughout the video. But yeah, I also do have a very special Christmas gift for you guys. Throughout the month of January, I'm going to be doing double uploads. So that means, because right now what I do is I upload a full-length video over the weekend, plus a short during the week. What I'm going to be doing throughout January is going to be posting a full-length video on the weekend, and then about halfway through the week, as well as a short. So 3 videos instead of just 2 every week. So yeah, I hope you guys enjoy, and let's get straight into the video. Okay, so imagine you have a mountain. So we can have a mountain here, right? And basically we want to find how steep that mountain is. So maybe there's somebody climbing it over here. So they're climbing it there. And it's really hard because it's such a steep like path, right? So maybe they're going to be like rock climbing or something. Meanwhile, somebody over here is going to have a much easier time climbing the mountain because they're pretty much super close to the top. They're like almost walking on flat ground. So we can like compare how steep the different parts of the mountain are, and that is what the derivative is. So derivative, that's derivative, okay? And the integral, which is integral, the integral just basically tells you how much stuff is inside of this mountain. So we can compare this mountain to maybe another mountain. So let's do a little hill here. So we have this little hill, and you can tell that this hill is smaller because there's a lot less stuff that's inside of this hill. You know, this one, it doesn't really have that much. Well, this one is made up of a lot more. So that's how we can talk about the derivative and the integral. Okay, so let me just draw a quick line here. Just some line segment, maybe it just goes off to infinity, right? And we know about the slope of this. Maybe we can say the slope is about 1, so I'll just say m equals 1. Let's just say that the slope is just 1, go up 1, over 1, you know. Okay, but, you know, we know how to find the slopes of straight lines, but what about the slope of a curved line? What if I had the slope, or what if I had the line like this, right? And we're trying to find the slope of this. Well, the slope is always changing, right? It's positive here, and then it's about 0 over here, and then negative down here, 0 again, and then positive. So clearly, at different places, there's going to be different slopes. Maybe we can draw a line, like maybe like through here we can draw like some sort of line that's kind of about the same slope, so it's something like this, like that. So that's kind of like a straight line that passes through that point. So maybe we can think of that and then try to find the slope of this line. But yeah, that's we can definitely compare the types of slopes we have. So really we're just extending our knowledge of this to this case, and this is called the derivative. Right, derivative. Okay, so what about area? So what if we try to find the area between here and here, right? Of this line segment. So like this whole piece of area here. Well, this is easy. This is just a trapezoid, right? We easily know how to find the area of a trapezoid. But what about the area between here and here? Well, this is really not a trapezoid at all. This is just a weird shape. And we really don't know how to calculate this directly. But with the tools of calculus, we're able to, if we know a little more information about the graph here, about this curve. But yeah, there are different ways to approximate it. You can just break it up into different shapes, try to get it close to equal in that way. And doing this, so really, this is what's known as the integral. And the integral tells us basically the areas of weird shapes. And that's really all there is to it. Okay, so we're going to talk about just some curve, and you guys are pretty familiar with curves and stuff. But we're going to talk about some things. First, I want to talk about the end behavior. So the end behavior on this, which you guys are familiar with, so as you go towards positive infinity, as x goes to positive infinity, y seems to be increasing, so it's going to go also to positive infinity. Here, as x goes to negative infinity, y is just decreasing, so it's also going to go to negative infinity. This is the concept of a limit. Specifically, we're taking the limit as x approaches positive infinity, and the one as x approaches negative infinity. So these are specific limits. We can also talk about the limits as x approaches certain values. Maybe we want to talk about the limit as x approaches 0. It's going to be some number, whatever this value is. We can call it like 3 or something. But note that the limit doesn't always mean f of x, you know? So like the limit, let's say if we want to talk about the limit over here, yeah, so the limit as we approach, we can call this 3, and we can call that corresponding value 3, right? Actually, let's do 4 here, just so it's a different number. So 4, right? So if we have the limit as x approaches 4, if we have an open circle here, that means the value doesn't exist. So f of 4, if this is f of x, f of 4 does not exist. But the limit exists. It's basically, like, as you approach from different sides, what are you going to get? Like, you're going to be really close to about 3, right? So even though f of 4 doesn't equal 3, because it's not there, the limit approaches 3. So that's the concept of a limit. The derivative, so let me write that down. The derivative is just the slope of the tangent line at any point. So we can say, what if we want the tangent line, the tangent line at this specific point, right? We can draw the tangent line, so it's something like this, and I'm sure you guys are familiar with tangent lines from geometry. But yeah, so this is the tangent line. It just like touches the curve once, doesn't cross through it. That would be a secant line. But this is just a tangent line, passes through it, and we can find the slope of this, and that's the slope of our graph at that specific point. Finally, I want to talk about the integral. This is the area under a curve, and we can approximate it. Let's say we want to find the area from, actually let me fill this back in. Let's say we want to find the area from here to here. So even though this looks pretty much like a square, maybe we had it more interesting, like that. Maybe our graph looks like that instead. We could approximate it by breaking this up into a bunch of rectangles. So let me actually fill this in. Maybe we had some rectangles here, like that, right? So we can pretend these are all like rectangles, and we can kind of like make these solid lines here, and we can approximate the area that way. Just basically, or we could use trapezoids, stuff like that. But these are the 3 major concepts of calculus, and I hope you enjoyed this video. Thanks for watching.